What is the purpose of isotonic regression? To predict values based on a monotonically increasing relationship. To transform data into a normal distribution. To remove outliers from a dataset. All of the above. True. Isotonic regression is used to predict values under the constraint of a monotonic relationship. This means the predicted values should either always increase or always decrease as the input. Feature values increase. LT font style quote font size 14px quotient. Isotonic regression is a type of supervised learning where a target values are constrained to be monotonically increasing or decreasing. It's particularly useful when dealing with data that exhibits a clear trend. LT font GT. False. Transforming data into a normal distribution is typically achieved using techniques like standardization or normalization, not isotonic regression. None. False. Outlier removal is usually handled by techniques like outlier detection algorithms or data cleaning. Methods. None. False. While isotonic regression works with monotonic relationships, it doesn't handle data transformation or outlier removal. None. To predict values based on a monotonically increasing relationship. A relationship whereas one variable increases or decreases. The other variable consistently increases or decreases. Consider a dataset where the input is the number of hours studied and the output is the exam score. If we observe that the exam score generally increases as the number of hours studied increases, this demonstrates a monotonic relationship. In other words, it's unlikely that studying more will lead to a lower score. This is a positive monotonic relationship. A machine learning approach where the model learns from labeled data, i.e., data with both input and output pairs. Let's say we want to train a model to predict house prices based on factors like size, location, and number of bedrooms. We feed the model data where each instance includes these features input and the corresponding house price output. This is supervised learning because the model learns the relationship between features and prices from the labeled examples. This technique is available in scikit-learn sklearn. Isotonic and allows you to enforce monotonic relationships between your features and target values. Let's say we have a dataset with the number of years of experience and the corresponding salary of employees. We suspect there's a positive monotonic relationship. More experience leads to higher salary. We can use isotonic regression in scikit-learn to create a model that predicts salaries while respecting this relationship. Rating systems ensuring that ratings consistently increase with better performance, e.g., product ratings, movie ratings. Imagine a website where users rate movies. We would want the ratings to be consistent with the quality of the movie. Isotonic regression could be used to ensure that if a movie has a higher average rating, its predicted rating is also higher. Price prediction, predicting the price of a product based on its features, ensuring that higher quality products have higher predicted prices. Let's say we're building a model to predict the price of cars based on factors like engine size, mileage, and year of manufacture. Isotonic regression could be used to ensure that the model doesn't predict a lower price for a car with a bigger engine and lower mileage, even if other factors might suggest otherwise. Calibration curves, adjusting probabilities in a classification model to make them more accurate. In a spam detection model, we might get probabilities for whether an email is spam or not. We want these probabilities to be well calibrated. Isotonic regression can be used to adjust the probabilities so that if the model assigns a higher probability of spam, it truly indicates a higher likelihood of being spam.